So guys, you're welcome once again to another video of mine from this is engineering from Mozilla Academy. And this is going to be chemistry first chapter I'm going to be releasing on YouTube about my chemistry takedown video, all concept line by line. And I'm starting with halogen and its compound. For efficient use of this video, you are advised to write down, get a paper, write down and make sure you jot every piece of point I want to talk about down. So I just want to use this particular slide to help you guys to understand chemistry work. How do I want to work? I'm working with your text materials. This is for all levels. So I'm going to be taking it line by line according to your textbooks. What you need to know, the observation you need to keep in mind. That is why you need to jot down. Don't assume. Watch this video till the very end because there are a lot of things you don't know. There are some of them you know. You understand? So you need to watch it to the end. And I promise you it's a line by line question, which I took my time to bring out from different resources, which I think is going to help you understanding everything you need to know about chemistry one by one. So I'll be taking it topically, chapter wise, and concepts will be explained with respect to the line. And these are past year questions, summation of different questions from different sources. So I have 100 questions before me, which are line by line for halogens and compound. I'll be talking along the questions. You need to write, you need to listen well, and get all what is required. So let's start. Now, the first one is halogen and its compound. The first question we have here is which of the following elements is the member of group 17? Now, as you all might have studied in your junior classes, that groups, there are 18 groups in the periodic table, modern periodic table. There are 18 groups. Modern periodic table, you have 18 groups. I just pray I don't have issue admin with all these my settings for today. So in the 18th group, the 13th to 18th group, the 13th to 18th group are basically called the P block. You just need to place it, the P block element. So the 18th group, basically from name, 18th group is called noble gases or inert gases. Old school periodic table, you call it group 8. Now, the 17th group, which is what we're asked here, is called the halogens, which is what we are focusing on here, which is a member of the P block. So they have a general configuration, NS2 and MP5. This is what always end their configuration. So note that halogens and their member, the members of halogens from junior classes is fluorine, bromine, iodine, astatine, and Tennessine. So you can keep it in mind. Now, these Tennessine and astatine are radioactive. In fact, when we talk about Tennessine is, or Tennessee, anyhow you pronounce it, Tennessine, which is the way I pronounce, Tennessine generally are, they are called artificial radioactive element because they have an half-life of about 0.05 seconds, so they don't last. You understand? So this is an artificial radioactive. So an intro to that is just for you to know they are highly electronegative. That is group 17. The last member definitely, because it's group 17, is going to be 117. The last member of group 8 is going to be 118. The one of group 18, which is group 8 in your own old school periodic table. So 118, 117, then group 16, 116. That is the way you move. So keep it in mind. 117, then bromine, everybody know me, number 7. Then the magic number we use, if you are hearing this for the first number, for the fourth time in the periodic table is 288, 18, 18, 32, 1, 2, 3, 4, 5, 6, 32. So this is like a magic number of elements in the group. So you can keep this in mind to get the atomic numbers of elements. I don't want to talk more because as I'm going, I say it's a line by line question. I'll still be talking about them, which will make you understand them. So these are the members of group 17 elements. The first member is 7. The next member will be 7 plus 8. So 7 plus 8 is I said 7. This is fluorine is number 9. Apologies. The first member is just what you need to know, number 9. 9 plus 8 are 17. 17 plus 17 plus 18. Please note that 2, 8, 18, 18, so 17 plus 18 are 35. 35 plus 18 are 53. Then you can move in that 53 plus 32. That is 85. 85 plus 32 will give you 117. And that is the atomic number of each of the member on the group 17. So answering this question, which of the following elements is a member of the group 17? Chlorine is there, fluorine is there, Tennessine is there. Answer to this first question by my admin today, line by line, is all of the above. So we move to the next question. Now, thank you very much. Now, the next question is group 17 elements are collectively known as dash. We talked about that just now. They are called halogens. We don't need to waste our time. I think I need to look at blue. Halogens are the name given to group 17 elements because they are called halogens because they are highly electronegative. And because they are salt producer. So you can keep that in mind as well, producer. So don't let us waste time. The next question, question 3 for today. Halogen means dash. Now, as I've talked about just now, you can say halogen means acid producer, salt producer, base producer, whatever producer. So what will be the answer to this one is a direct question now. I said they are salt producer. We can actually prove that because when hydrogen combined with metal, please be careful about that. They produce what? Salt. You understand that? So that is a simple question. I believe you all can get that. Question number 4. Number 4 says halogens are dash non-metallic elements. Now, I told you because they are some of their characteristics highly electronegative, concept. Because they are highly electronegative, you know, it means they almost form octet. Fluorine is even said to be the most electronegative. We are going to talk about the trend very soon. Fluorine is said to be the most electronegative. All of them are what? They are they are highly reactive. Highly reactive. Why? It's because they don't easily ionize. Please note that. So ionization enthalpy is high. They don't easily give electron. So they have high ionization enthalpy. So they have high electronegativity. So note that. So those are their common characteristics. So they are very, very reactive. In fact, they are said to be the most reactive non-metal. Because you can see if you write this old school, you say 2,7 configuration. If you want to write new, we say 1s2, 2s2, and 2p4 plus 5 and 9. 2p5. I told you ns2, mp5 is their general configuration that ends every member of the group 7 thing. So without wasting time, I hope you guys are getting this. They are very, very reactive. Is the correct answer to this. We can move to the next question. Next is, now, which of the following halogen is a radioactive element? I told you from the first explanation that the last 2 members are radioactive elements, which are astatine and Tennessine. So the correct answer to this is both A and C. Please, they are not stable, and that is why most of them are seen as being radioactive in nature. Next question. Now, the most abundant halogens is or are dash. Now, talking about abundance of halogen, it is just with respect to their position in the periodic table. Now, when we talk about the position in the periodic table, we should keep in mind fluorine, F and chlorine are the most abundant. They are the first 2 members. Those are simple logic. Are the most abundant. Then we can talk about bromine and iodine is next. And astatine and Tennessine. They are They are not They are scarce. I hope the spelling of my scarce is correct. So this one are not common and not that common. So it's a good thing you can keep in mind. That is that about that. So the correct answer to this one is nothing but fluorine and fluorine. The next question. The next question is in which of the following fluorine is present? In which of the following is fluorine present? I guess that's what I didn't want to say here. I hope I am right. So in which of the following is fluorine? Is you come here, is fluorine present. Now, talking about most of the fluorine, the first member, we have to carefully look at them one by one. Now, fluorine is found as what mostly they are found in terms of ore. Most of the fluorine are said to be an insoluble ore. Please write down, it's important, insoluble ore, and they are mostly seen as number one is what we call fluorspar. Fluorspar. Fluorspar is when what calcium combined with fluorine. It is written as CaF2. Very important. The next one is also ore. Another ore you can see fluorine is the one we call cryolite, molten cryolite. I think this one is common in junior classes. You are talking about extraction of aluminium. Remember, you have a NaAlF6. I hope I am correct. I'm sure I will be correct. Then the next one is a fluoroapatite, which is most of the fluorine are seen in this one. So fluoroapatite is like it is written as a Ca3PO4 odd twice plus some molecule of our calcium chloride, blah blah blah. But in fact, we have 3 molecules sometimes to Ca3PO4. So what I'm trying to say in essence is that most of fluorine are seen in ore, which are insoluble ore, and they exist in fluorspar, they exist in chlorite, they also exist in fluoroapatite. So the correct answer to this question, my dear student, is this. And this is very correct. Please take note of this. This is a common question you can see under extraction of metal as well. The next question. The next question says, now we have concept, we can now answer the following question. Which of the following is correct chemical formula for fluorspar? I just talked about that. Then we talk about CaF2. I talked about this just now. We don't need to waste time. Next question. The next question says, which of the following represent cryolite? I talked about cryolite, not quite long. This is the answer for cryolite. Nothing to waste time about. The next question asks us, which of the following is a chemical formula that represents fluoroapatite? I told you about this. This is fluoroapatite. We can move to the next question. I hope you understand. Chemistry is about reading line by line, taking note of different observations. So there's nothing hard in chemistry, to be honest. If you are a type that you are so careful and you read in between lines, very important, and you write down observations. Next question. The next question is seawater mainly contains, I think this is only 2 options. Now, we can also keep it in mind that talking about halogen and its compound. So the constituent of seawater contains sodium chloride solution. Sodium chloride solution of about 2.5% by mass, and a lot of and some amount of fluoroapatite, and another particular ore we talk about, we call it carnallite. Please keep it in mind. It's also very important. Carnallite. Carnallite is just a mixture of magnesium and sodium chloride with 6 molecules of more water. So you just need to keep that in mind because sometimes you might come across that. So the mixture of seawater, most seawater contain sodium chloride of about 2.5% by mass mixed with carnallite. So keep that at the back of your mind. So the correct answer to this, even though the answer is not up to D, the answer is still there. This is the correct answer to that. We can move to the next one. Next question, it's a line-by-line concept class. Relax yourself. You don't have issue. The deposit of dried up C contain dried up C. So C content, I told you, it contains sodium chloride and what? And carnallite. Answer to this, my dear admin, what will be the answer now? Admin say D. Yes, very correct. So both A and B is correct because dry up C contains sodium chloride, and carnallite. Sodium carnallite is a mixture of magnesium chloride, sodium chloride with some molecule of water. Now, the next question. Fine. Now, we have which of the following is a chemical formula for carnallite? Now, I can help you write. Carnallite is a mixture of potassium chloride and magnesium chloride with 6 molecules of water. This is what I told you. So it can also be sodium chloride and magnesium chloride. Be careful about it because in some cases you can see NaCl. So potassium chloride, magnesium chloride with 6 molecules of water, and this is the composition of what we call dried sea. It is found in dry sea. So always keep that at the back of your mind. So that is canalite. Which option goes with this? Now you know this is fluorspar, this is cryolite, this is canalite, and this is what? Fluoroapatite. Please keep it in mind. You have to follow me line by line to understand all the concept that is in there. So correct answer to canalite here is this option. We move to the next question. Now, the next question says, which of the following is the synthetic radioactive element? If you follow me artificially, synthetic wise, you will understand that I talked about what? I told you that tennis is an artificial radioactive element and have an half-life of about 0.5 seconds. I talked about that. So this is the right answer to this. Tennis or Tennessine is tennis. So that is the spelling of that. So the next question should be, next one. Now, which or what is the symbol of tennis? Tennis, we've talked about that in the introductory part. We said it was what? This one. I hope students still remember. Admin, do you still remember? Very good. My admin is nodding his head right here. So the next question. The next question is, what is the atomic number of tennis? Tennis is the last member of group 17. It's going to be 117. The last member of group 18, 118. The last member of group 16, 116. The last member of group 15, 115. The last member of group will continue in that manner. So 13 to 18 are called P block, and the answer to this is what? This. As at now, there are 118 elements in the periodic table. Tennis is what? The last but one, penultimate element. I hope you understand. Penultimate element. Then the last element is, I think, organism. Organism should be the last element in the periodic table. The next one should be, we have next question. The next question is the electronic configuration of tennis. Tennis is 117. We've talked about that. And we say general configuration of halogen is NS2MP5. So it should be NS2MP5. So we have N now, then tennis is in the 7th period. So please note that tennis in the 7th period. So because it's in the 7th period, wow, it should be, admin please, watch what I'm doing please. It should be in the 7th period that you can control anything that you need to adjust. So, and that means N will be 7. So it can be this, it can be this, and this is not the general configuration. So definitely this is the answer. And again, it should be the highest noble gas. And that is why we are taking this. You should know it should be the highest noble gas that is close to tennis. And this is what? Radon. So keep that at the back of your mind. Next one should be the next question. The next question says the general electronic configuration of halogen, we just talked about that. NS2MP5 is the answer to that. So the line by line will really help you guys to understand most of this concept easily. Which of the following are the smallest atomic radii in their respective period? Now, listen, a new concept you can learn. Halogens. Halogens have smallest atomic radii in their respective period. Thank you. Respective period due to the fact that they are one electron away from forming an octet. I hope you understand group 17. Almost they are close to noble gas. So that is why the atomic radius in each of the period, they have the highest. You know, they are very close. They only need one more electron. That's why they are electronegative and they are powerful oxidizing agent. We still talk about that with time. So now keep it in mind. They don't easily what? They can't give electron because they are already what? Very close to what? The bond lengths are very tight. They are very close to each other. And because they are very close to each other, they don't want to what? They don't want to actually what? Give out what? Any form of what? Any form of electron. They actually what? They will accept because they are non-metal. You know that very well. So because they are very close to to their octet shape, they actually have the smallest atomic radii because their bond length is close. So note that. That's another good point. So always keep it in mind. And another thing you can say, because we call it because of the atomic number, that is what we call Z effective. We call it. I'm waiting for this to come up. Admin, I think I'm having issues with what I'm writing. I hope you guys can still hear me. So let's wait for this because we still have a long way to go. I think I am back. Hopefully, I am back for good. So if you can hear me, let me know. I hope you can still hear me. Wow, very good. So we can move on. So I said because of Z effective, that is just what we are talking about. That is their nuclear charge. You know, they are now very close. So the nuclear charge, that is one of the reasons whereby what they have the highest what they have the smallest, not the atomic radius in their respective period. So that is the characteristics of halogen. So another thing you can just keep in mind now, nitrogens are group 15, which you call group 5. Chalcogens are group 16, which you call group 6. Noble gas are group 18. And of course, halogen are group 17, which is the answer to the question we are talking about here. So please keep it in mind. We can move to the next one. Admin, please, the word full. Now, the next one, the halogens are the smallest atomic radii in their, you can see, continuation. That's why I call it a line-by-line concept. In their respective period, due to the maximum, I just talked about this now. Now, what do I call it? Effective what? Nuclear charge, Z effective. So always keep that in mind because they are very, very, very close to each other and they are not ready to lose electron. You know that they cannot give, so they are ready to gain. So because of that, the effective nuclear charge is small, and because of that, they are going to have small atomic radius in their respective period. So this is the answer to that, and that is what we are talking about. The next one. Next question says, which of the following elements of the group 17 element has the smallest atomic radius in its group? You can keep this in mind. Atomic radius of halogen. Atomic radius, this is just like more of periodic table concept. Atomic radius of halogen decreases down the group. This is because, you can put it in mind, this is because the atomic size or atomic number increases. Atomic number increases. So atomic number increases, electronegativity will decrease, ionization energy will decrease, effective nuclear charge will also decrease. The bond length is also what? They are now increasing. So please keep that in mind. This is a simple question. So if we go by that, you know the trend, it is fluorine, bromine, I said for bromine, fluorine, chlorine, bromine, iodine, and astatine with what? Tennis. So it should be fluorine, chlorine. This is the way they go. Bromine, iodine. Please watch the video to the end. And you have astatine. And the last one is what? We call it what? Tennis. Don't forget. It's very important. So that is the way they go. So the one that has the smallest atomic rate, I said it decreases down the group. So you should go for the one that is lowest in this trend. Out of this trend, the one that is lowest here is A. And that is the answer to the question. So we move to the next one. Now, the next question says atomic radius and ionic radius increases from, we just talked about that, they increases from, hope you understand, increases, because we said they decreases down the group. So they will increase from what? From down to up. So we say down, just right, they say no option said down to up in the periodic table, in the group of the periodic table. I hope students understand that. The next one, the next question says atomic anhydride increases from fluorine to iodine. Please note that due to increase in the number of shell. Please note that they increase like that. So atomic radii, please let me say, hope I did not make mistake in my concept I'm explaining. They said, which of the following groups of 17 elements have the smallest atomic radii increases than the group due to size? So please, increases, apologies about that, increases increases down the group. So please correct that because of increase in atomic number. So if it increases, we are looking for the smallest one. The smallest one will be what? Fluorine. Please, apologies about that. That is why you need to be careful. This is a basic something everybody knows. Because of the size is increasing, you expect what? Atomic radius also to what? To increase. Please keep that in mind. So the next one should have been this. Let's correct that. So atomic radius increases down. You can see, I was right. Increases from what? Increases from what? Up to down, not down to up. Yes, up. You can see like it increases, or let's say it increases from fluorine. Let's just write it another way. From fluorine to iodine. I hope it's better in that way. As you are going down, you expect atomic size to increase and atomic radius will definitely increase. Very simple and basic. Please. Now, the next one. The next one says atomic and ionic radii of fluorine increases from fluorine to iodine due to increase in, I just talked about this, the quantum shell, the size. The shell increases as you go down the group. Please note that. And this was even what actually made me to understand that I have made a mistake in my answer. So please keep it in mind. The next question. Now, the next one, the correct order of covalent radii of halogens are dash. Now, covalent radii. So be careful about this. You understand what we call by covalent radii. When we say covalent radii, it's still the same thing. Now, because most iodine, you can see they are non-metal. Non-metal definitely form covalent bond. You know that very well. So it will increase from fluorine to chlorine. You can see fluorine, fluorine is bigger than chlorine. Chlorine is bigger than bromine. Bromine is bigger than what? Iodine. Please note that because of increase in what? The same thing. So we can move to the next one. That is the answer to this truth. The next question, line by line question. Watch the video to the end. The next question says the correct ionic radii of halogen are either atomic or ionic radii. Still the same thing, increases from what? Fluorine down, then it goes what? From fluorine, then it goes like that. So don't make mistake. That's what I told you. As this is increasing, you also expect it. So this is also the answer. Both ionic and atomic radii, they behave in the same way. So keep that at the back of your mind. So the next one, why? Because of increase in the cell, in the shell, in the sites. So that is why atomic and ionic radii tends to increase, as well as the covalent radii. Now the next one says why halogens have little tendency to lose electron. I just talked about that. The reason is because they do have what? High ionization enthalpy. They don't lose electron. Halogens don't lose electrons because they have high ionization enthalpy. Now, what do we call ionization? You know the meaning of ionize. They do not easily ionize because it only remains one electron for them to complete octet. So that means they have high ionization enthalpy. So keep that at the back of your mind. So they don't lose electron because they are very close. The electron repulsion in them is very, very what? Is tight. So because of that, something that is close to forming an octet can never give you an electron. Do you understand? So it has a very high ionization enthalpy, not a low one. The ionization enthalpy is low, is high, and they don't easily give what? Electrons. They cannot give electron. That is because they are high, they have high ionization enthalpy. So A is correct for this one. The next one is for halogen, ionization energy dash down the group, just the way we've talked. We talked about just like the way the normal fluorine is greater than chlorine, chlorine is greater than bromine, bromine is greater than iodine, just the way we talked about the other time. So the same formula still holds for ionization enthalpy, for atomic radius, for ionic radius, for their covalent character. You have to keep all these things in mind. You have to watch you to follow me line by line. So what happens is that you can say fluorine, chlorine, bromine, iodine. So it's not a regular trend. They have a particular trend. You can see fluorine is greater than chlorine, Fluorine is greater than bromine. Bromine is greater than iodine. So when we talk about them, we say as you are going down, they also what increases than the group. So they increases than the group. So just like the way we've talked about in type of size too. So it's also the same thing that you follow. The next one, the next question says, admin, next question. So the next question, I hope you are still there. Wow. Now, ionization decreases than the group in the case of halogen because dash. Ionization energy decreases than the group. What am I picking here? Let's check, please. I said fluorine is greater than chlorine, is greater than bromine, is greater than iodine. So what this means what? It's what? It decreases. You guys, thank you, Admin. Admin was the one that asked me to check that previous one from my explanation. From what you can see here, please be careful about all these things. When I say fluorine is greater than chlorine, is greater than bromine, is greater than iodine, it means what? They decrease because this is their trend than the group. Don't forget that. So please, the answer to that should be decreases. You know, the trend is fluorine, chlorine, bromine, and what? And iodine. So if I say fluorine is greater than chlorine, is greater than, so this is the trend. So it should be what? Decreases. Don't let inequality cause problem. So the next one says ionization energy decreases than the group in case of halogen because of their dash. Now, the reason is because of what? The what? As you what? Because of what? Of their atomic what? Now, we can also explain this in two ways. So I will explain it better. We say they don't easily what? They don't easily get what? Give electron. They have what? High ionization enthalpy. That was what I told you, right? Now, if I have explained that, the reason because they decrease down the group is because what happened to the atomic size? The atomic size is also what? Decreasing. The size of atomic size is what? Is decreasing. So if atomic size is decreasing, you expect them to what? To also have what? High what? Ionization energy. Ionization energy to also decrease than the group. So please, important point I want you to keep that to avoid confusion is atomic radius, ionic radius, this increases. Ionization energy and electronegativity. Important point, this decreases. Now, ionization energy, ionization enthalpy, please note that enthalpy is its change. When it is subject to a substance, it can absorb and it can what? Release. You know that. So this is just what we have been talking about since morning. So don't have, so ionization, the reason why this happen because what? The size of what? The atomic number increases. That is it. And the reason why this happen, we've talked about that, is because what? As you go down the group, you expect what? The atomic number to decrease, and hence what happen? Electronegativity what? Also what? Decreases down the group. As you go down the group, electronegativity decreases. You all know that from basic classes. So what I'm teaching so far so good is because fluorine has the highest electronegative, followed by the next one, chlorine, followed by the next one, followed by the next one. The same thing to ionization and that. But when it comes to atomic size, ionic size, and you can slash this and covalent bond, you follow this increases. So to just keep it simple and not too hard. So the next one, the next question says the correct order of ionization enthalpy for halogen is dash. Now I just talked about it. So when we say it's decreased down the group, this was the chart I gave you the other time. Fluorine is greater than chlorine, is greater than bromine, is greater than iodine. Admin, I hope you are following so that you can point any mistake if you spot any, because most of the time I will explain something while picking answers, I might go and tick the wrong one. So I don't want that to occur here, and that is why I just want you guys to be attentive. The next question. Now, which of the following have the maximum negative electron gain enthalpy? Now, let's talk about electron gain enthalpy. Electron gain enthalpy of halogens decreases down the group. This is because we said fluorine is mostly electronegative. So electron itself, you guys know electron is E minus. So if you say the next one is now fluorine, which is Cl minus. Cl minus is a little bit more electropositive than F minus. So it has what? Electron enthalpy, it is what? It is nearing positivity than fluorine. So as you go down, you expect what? The electron gain enthalpy to be what? To be going down, because they become more positive as you are going down the group. Fluorine, bromine, and iodine. So this is what I will use. So as you are going down the group, you expect it to be what? To be decreasing. So note that. So which of the following is the maximum? We said which of the following have the maximum electron gain what? Enthalpy in corresponding period. You know, I have only given you with respect to the group. So if it is decreasing down the group, what do you expect to the period? It will now what? Increase across the period. So I hope you are following. These are things you have to keep in mind. And that is why we are picking halogen as our answer. They have the highest negative electron gain enthalpy across the period. They also have the highest what across the period again. We've talked about that if you are following admin. Very good. My admin are really following. So they have the highest negative electron gain enthalpy across the period. Basic. Then we also say they have another thing, they have the highest one, they have the smallest. When you go across the period, because they are very close to their octets, you expect them to also have what their highest what electronegativity. The electronegativity also increase across the period. Do you understand? So all those things are very important for you to develop that problem. So the next question, don't let us waste time. Now, halogen have the maximum negative electron gain enthalpy in their corresponding period because one, atoms of this element have only one electron less than the noble gas. I've talked about this. This was what I explained. So they do have what? Highest electron gain enthalpy because they only need one more electron to complete octet. So atom of the element have, this is a simple question every one of you can get. So that is why the electron gain enthalpy, negative electron gain enthalpy is maximum across the period because they only need one electron to complete octet state. So please don't make mistake and don't mix them together. And that is why I'm taking it line by line. The next question. The next question says electron gain enthalpy of the element of the group 17 become dash down the group. I think I talked about it. I said down the group, they decrease. Across the period, they tend to what? Increase because they become more positive as we are going down the group. So I just talked about that. So this will be the answer. They become more positive, or let's say more positive is less negative. I like chemistry. That's chemistry for you. They become less negative would be the answer because we are talking about what? We are talking about halogens, which are what? Highly electronegative. So as they go down, electron enthalpy becomes what? Less negative. Please note that. So because you can say mathematics why they are more positive is written as less negative, not in chemistry where because we are talking about electronegative element, they become less negative. That is the reason for that. The next question. About this, we say the negative electron gain enthalpy of fluorine is dash to chlorine. Language of what we have explained. So we said fluorine, as they go down, they decreases. As they go down, negative electron gain enthalpy. I told you, if you are forgotten, I can show you because all these things are things you have to follow line by line. And that's why I call it line by line concept. See, across the period, they increases. Down the group, what happens? They decreases. So if I said they decreases down the group, just for explanation's sake, because I may not be writing in some of them because they are line question of what I've talked about. So now look at this now. It's now language form of what you have done. The negative electron gain enthalpy of fluorine is dash that fluorine. So as we said, as they go down the group, they decreases. Electron gain enthalpy decreases down the group. So now what we are saying is that if they decreases down the group, fluorine will be what? More than fluorine. I hope I'm communicating. Do you understand? Electron gain enthalpy of fluorine, negative electron gain enthalpy of fluorine is more than that of fluorine. I hope you understand. It's a very simple question. Not simple if you are not following the line by line or explanation. For halogen, the electronegativity dash the group. They increase across the period. We've talked about it. Just like negative electron gain enthalpy and increases in period and decreases than the group. Important things. So now the answer to this is what? Than the group will be what? It decreases. I hope you are following. Next one, admin, hope I am there. Next question, I don't even know number at which we are. We have 100 questions before us. Which of the following element is the most electronegative in the periodic table? Do you know that we talked about that fluorine is the most, the trend is FONCl. You can continue like that. So the answer to this is fluorine, and we don't need to waste our time about this. The next one, excuse me. The next question, I'm waiting for admin to pop it up. So let's wait. I will wait. I think it's loading. Now, physical properties. Now, I think we are now in the aspect of physical properties of halogen. Now, talking about physical properties of halogen, most of the halogen, we talk about how they exist. Now, you can quickly talk about some facts. So, a physical property you can always keep at the back of your mind is that when we talk about halogen, we say in terms of their state of matter, fluorine and chlorine are gases. That's the important point. Next one, in terms of physical property, is that we said we said iodine. We also have talk about bromine. Iodine is solid. Then bromine is divalent. You know, bromine is liquid at room temperature. So now the thing you also need to know about some other physical property. I'll be talking about it line by line, just for you guys to follow through. Please write down. It's important. All halogens are colored. You can write that. All halogens are colored. And this is because they absorb, the reason for their coloration is because they absorb UV light, ultraviolet ray, absorb ultraviolet radiation from the atmosphere. That is why they are colored. So talking about the color, you guys know fluorine is yellow. Fluorine is greenish yellow. Maybe I should have used yellow marker. My admin here like yellow very well. But I always think yellow is not writing well. I don't know. Iodine is purple. To me, it will not write well. Iodine is purple or violet or whatever you call it. Or blue, black, or whatever. Bromine is red. So that's the color. So let's start. Which of the following of the halogen is all are gases? Fluorine and chlorine are gases. And because the two are gases, so we'll pick answer to be choice option D. So please note that. The next question is which of the following halogen is solid in its physical state? We talked about that just, and I told you I want to recall just for you to see. I2 is solid, and that is why I'm going to pick iodine as being solid. That's the answer. The next one. Which of the following statement is correct regarding halogen? All halogens are colorless, all halogens are colored. I talked about this just now. All halogens are colored. Admin? Yes. Now, the next one, 74. Now, not question 74, maybe question 20 something. I don't even know. Now, all halogens are colored due to, I think I was absorption of radiation invisible. I talked about this. This is the answer. Line by line are always good. So we can increase our pace. The next one, what is the color of fluorine? Fluorine is yellow. I talked about it. You can check the note I gave to you just now, line by line concept. The next one, which of the following option is correct? Fluorine greenish yellow, iodine violet, bromine red color, all of the above is correct. We can move to the next one. Physical properties are simple to know. The next, watch this video till the end to have maximum knowledge. Which of the following statements is or are true regarding fluorine? Fluorine is the most electronegative discussed. Yes. Fluorine reacts with water. Fluorine have less electron gain enthalpy than chlorine. All of the above. Yes, I think all of the above is correct. Most electronegative element is fluorine. Fluorine reacts with water to form hyperchlorous acid. You can keep that in mind. I'll still talk more about that. Fluorine have less electronegative gain enthalpy. We talk about the trend, it decreases than the group. Admit, don't sleep on bike. They have less, so this is correct. This is correct. Fluorine reacts with water to form oxygen, to form hyperchloride, to form oxygen. We're going to talk about that now. So all of the above is correct to this, and this will be the answer to this question, because all these are what we've talked about in the concept of fluorine. So now we move to the next one. The next one says, which of the following is which of the following reacts with water? Now, we have fluorine reacts with water, fluorine reacts with water. So both A and B should be the correct answer to this. Fluorine reacts with water to form oxygen. Fluorine reacts with water to form oxygen. Fluorine reacts with water to form hypochlorous acid or hyperchlorous as hyperchlorous. So you can say HOCl. So I'm still coming to that. I will explain that in due time. The next one. Which of the following oxidation state is exhibited by halogens? Now, halogens generally they have general oxidation state is what? -1. I told you they need one. That is when we talk about electron gain enthalpy the other time. So their general oxidation state is -1, which is the only oxidation state that fluorine can exist. Fluorine can only exist in what? Only have what? -1 oxidation state. The reason is because it has what? An absence of d orbital. You no get d orbital. So they don't have d orbitals. So because they don't have d orbitals, they only have -1 oxidation state. Whereas other halogen can exit what? They can have +1, +3, +5, and +7. So you can also keep this in mind because they have what? They have d orbital. So fluorine don't have d orbital. And this is even attributed to the anomalous behavior of fluorine. Write it down, is a good point. Anomalous behavior of fluorine. So anomalous behavior of fluorine is because it has high electron. You can attribute all the factors we have been talking about since morning as the reason why fluorine behave anomalously. Low electron gain enthalpy, high electronegativity, high electron and high ionization enthalpy. Which other one did I talk about? Absence of d orbital, low small size. All these are the reasons why fluorine behave what in an anomalous way. So this is the general oxidation number OS of halogen group. The next question, may I help that with me? Please don't sleep on by. You can take a walk. How many oxidation states are exhibited by chlorine, bromine, and iodine? Oxidation state of what? I told you about that. All of them exhibit -1. You can see +1, +3, +5, and +7. This is the only one you can see. 1, 2, 3, 4, 5. Final answer? 5. I hope you are following. Follow and watch this video to the end for you to have maximum knowledge on halogen and its compound. Halogen react with dash. Halogen can react with metals. They can also react with non-metal. So the answer will be both metals and non-metal. Please keep that in mind. Halogen reacts with metals and they also react with non-metal. They also react with themselves. Halogen plus halogen react with themselves too. So we call it the action of halogen plus halogen is called interhalogens. Halogens plus halogens is called interhalogens. 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 I think something has shaked. Maybe admin can help me just plug my charger back. The charger of the laptop is out. Interhalogens. It's just the laptop. Yeah. So interhalogens. Not yet. Apologies, guys. I'm working on the laptop. Don't shake that too much. I don't think this is charging. Just a minute, please. So answer to that is they react with both metals and non-metals. I told you. Interhalogens, they react with oxygen. Halogen react with oxygen to form oxide and oxoacid. So they also react with non-metal. So we talk about that in sequence as well. So the next one. Halogen reacts with metals and non-metals to form dash. Now, metals and non-metals to form, they call it reaction of halogens. Let me just halogens plus metals, or halogens plus non-metal. They call it halides. They call it halide. So please note that. So we say halides. So they are called halides. So halides, 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 halides. So that's the answer. The next one. The reactivity of halogens towards metal and non-metal are the order of that, just the way you have learned before. When they react with metal and non-metal, they follow the same trend, which we say fluorine is greater than chlorine, is greater than bromine, anomalous behavior of what? Of fluorine. So nothing to waste time about. This is the answer. Note that. The next one. Which of the following is the reason for the strong oxidizing agent or nature of halogen? Now, they are strong oxidizing agents. In fact, the reason why they are strong oxidizing agents is because, one, they have, I told you, they have small size. I've explained that before, and they are highly electronegative. So, because they easily combine, their oxidizing ability is the reaction of halogens. Keep it in mind. Can react with oxygen. I hope you are with me. They can react with oxygen to form oxide and oxoacid. Now, they can also react with metals and non-metals, which I talked about, to form what? Halides. So these are what you need to keep in mind from now. And also they can react with water. I've talked about that. Fluorine reacts with water to form oxygen, whereby others react with waters to form what? Hypochlorous and hyperchlorous, which we are still going to talk about. Please try and watch this video to the end. So we can say the reason is because, one, oxidizing, they have small size, they are highly electronegative, and they are ready to what? To accept electron. You know that definition of oxidizing agent is what? Ability to what? Accept electron. So because if they accept the electron, they will get reduced. So this is correct. This is also correct. So definitely this is going to be the right answer to the question. The next one. Which of the following, which one is the strongest oxidizing halogen? We've talked about that. I don't think I need to talk about this again. Fluorine is the strongest oxidizing halogen. In general, a halogen oxidizing halide ion of dash. Wow. Now, oxidizing power of halogen. Now, I told you, most times you guys say it is because how they oxidize. You can say because of what I said, it's kind of a reaction you call displacement reaction. It can displace each other. Now, it displaces its own self of what? Halogen displaces another halogen of high atomic number. What am I saying? You know, generally we denote halogen by X. You might have studied this under your organic chemistry, which we are still going to talk about. We are through with all physical chemistry line by line. It's not easy, but it's a promise. By God's grace, we are going to finish all. So now, what I'm saying is that if you have fluorine is the strongest, we talked about that. Fluorine is the strongest. So if fluorine combined with okay, we have an halogen, maybe XCl. If it will displace this, let's say XM or XM, just say X alone for understanding sake for now. So this S can be any metal or any group member that is under fluorine. I hope you are getting it. So fluorine displaces I, the one that is what? That is what all halogen displaces the one that is under it, the one that has high atomic number than itself. So that's how they work. That is how the oxidizing ability is built. So from the knowledge of your displacement reaction, so the answer to this should have been higher atomic number, and that is the answer to that. The next question. Now, what is X and Y in the given reaction? I think this one will explain what I'm trying to say. Now, we know the oxidation number, talking about oxidizing ability. The oxidation number of this guy is what? Is 0. Then when it reacts, it will increase, it will what? It will decrease what? It will decrease its oxidation number. So when there's what? A decrease in oxidation number, we said such thing is what? Any element that got itself reduced is what is an oxidizing agent, early classes. So it will now move from F2 now to what? Apologies, admin, please work on this. I think we have a technical error, which we hope it will come back in time. Now, as I was saying, so now what happened here, because you can see X is chlorine, bromine, and iodine, which fluorine is going to what? Is going to oxidize. You understand? Fluorine will oxidize any member that has high atomic number, just like displacement, it will displace it than it. So it's 0 to -1. So this X will be F minus. I hope you are getting it. What is the oxidation state of this radical? -1. It will now what? It will oxidize this X into what? From -1 to 0 to what? To X2. And that is what I was explaining the other time. So the correct answer here will be this guy. So this is the answer to this, talking about the oxidizing ability of fluorine. Next one. The next question is what would be X in the given reaction? Look at this now. What is this, guys? Chlorine. Chlorine can only oxidize or displace the one below it. So this guy can never be fluorine because fluorine is above it, what we talked about just now. So now what you do now in this type of situation is look for anyone that is below. Bromine is below chlorine to oxidize it. Iodine is below. So the answer is both A and C. Watch this video to the end to understand full concept. Next one. What is X in the given reaction? Bromine. Bromine will oxidize, you know. We have fluorine, chlorine, bromine, iodine, and astatine. So bromine can only oxidize what? Iodine, which is under it. So this will be the answer. Same concept, line by line. So the next one. Thank you. Now, in aqueous solution, the oxidizing ability of halogen dash down the group. Now, in aqueous solution, please note that that is when they are dissolved in water. When you dissolve halogen in water, the way they behave in what is still the same way they behave. Oxidizing ability definitely will decrease as we are going from fluorine down to halogen. So please note that. Please note that. Let's see, we can take an instance to see in aqueous solution. Okay, that is if I add water to there, oh, the answer should be the increase. Sorry about that. It is increased. Let me just help you write it in language form. Halogen increase, halogen increase, increases down the group in aqueous solution. In aqueous solution due to the affinity of chlorine and iodine with hydrogen. So you can keep that, or you can also say due to the polarizing effect of chlorine and iodine, which you cannot see in bromine and also in what? In fluorine. So increases will be correct to that. Please, another important point, line by line, please follow up. The next question will be this. Fluorine oxidizes water to dash. I told you the other time, it will give oxygen. Fluorine will oxidize water to give you, please be careful about this, it will give you oxygen. Oxygen. So please, oxygen is what we are going to liberate when fluorine reacts with water. Please note that. The next one, I told you it is chlorine and bromine that give hydrochloric acid and hydroallic acid. So chlorine will oxidize into water because fluorine is more of a highly fluorinated substance. Highly fluorinated. So fluorine is more of a fluorinated fluorine. I hope my spelling is correct. Fluorinated agent. So it's actually what? It's combined easily. I get it now. It's fluorine combined easily with what? With this. Now, it's want to add fluorine to hydrogen than hydrogen add itself to fluorine. So fluorine acts as a fluorinated agent and not an oxidizing agent like fluorine and iodine. So please note that it's a very important thing you can keep. In fact, one of the reasons we use this word, we use fluorine. Fluorine is used as to are the fluorinating agent in plutonium. I think plutonium P4O6. Yes, we use fluorine to what? To fluorinate, to remove plutonium from a mixture of other radioactive substance. So important point you can keep in mind. This is for all level, and that is why I'm taking all line by line concept. So that is the answer to that. The next one we can see. Next question. Thank you. Now, chlorine and bromine react with water to form, I talked about that, hydroallic acid and hydroallos what? Hydroallic and hypoallos acid. So please note that they don't form oxygen. So only A and B is correct for this one. Fluorine will oxidize, we fluorinate. That is why it is from giving oxygen. Whereby chlorine and this thing what we oxidize, and that is why they have what? They form hydroallic and hypoallos. And again, because of their polarizing effect with water, they easily polarize with water more than fluorine. Now, next one. The next question is what is Z and Y in the given reaction? This is chlorine and this is bromine. Admit, please. Now we have this, if it is chlorine and bromine, you know, they are going to give what? They are not going to give oxygen. They are going to give what? Hypoallic acid and hydroallic acid. We talked about that in the previous slide. So be careful about that. So I'm looking for, yes, this is it. Dissolved in water is going to give you hypoallic acid. This is HOCl. You can see this is correct. Z is HOCl or HOBr. So whereas what? Oxygen plus Y, which is oxygen. So this is the answer to the question. So please keep that in mind. The next reaction. Now, the reaction between iodine and water is that. Now, iodine combined with water is said to be a non-spontaneous reaction. Iodine combining with water is said to be a non-spontaneous reaction. Please note that it does not occur naturally. It's a kind of reaction that occurs artificially, man-made reaction. When you combine iodine with water, most iodine substances are insoluble in water. So when you react iodine with water, it's a spontaneous, I say non-spontaneous reaction. So please note that. The next one. The anomalous behavior of fluorine is due to, I think I've talked about that, all those properties. It has a small size, it has high electronegative, it has low bond dissociation enthalpy, that is their bond length is short, right? It has what? Absence of what? D orbital, absence of D. There should be D here. There's absence of D orbital. So all these are what I've explained. If you are following my line by line explanation, and that is why the answer to the question will be all of the above. The next question, 96. The next question says, which of the following halogen forms only one oxo acid? Which of the following halogen forms one only oxo acid? Now, oxo acid, that is let me just help you out. Fluorine combined with oxygen to give us OF2 and O2F2. So these are two oxo acids. The action of fluorine, that is what we use to detect is what we say sometimes bleaching property. Sometimes I'm still coming to that. I don't want to rush. I want to take it gradually the way it should be taken. So just relax. So this is halogen combined with oxygen to form this. Fluorine combined with oxygen to form this. Fluorine can combine with oxygen to form. We have Cl, OCl, ClO2, Cl2O3, ClO5, Cl2O5, and OCl, ClO2, Cl2O3, Cl2O5, and Cl2O7. So these are what you can see for fluorine when they combine. You can also combine the next one, iodine. Iodine can also combine with oxygen to give you I2, I2O3, we have I2O5, and I2O7. Let's write these two now, they are very important. I2O7. I'm writing, I think I'm waiting for this to come up. It's still loading, you guys are used to this. Let's wait for it to come back. So I2O7, I2O7. So now, we got this one is, there's also OCl. OCl, ClO2, Cl2O3, Cl2O5, Cl2O7. So now, from what I've explained here, you can see which of the following form only one oxoacid. Then we can say the answer to this will be nothing but what we can say. Most of what is here, the only one I did not talk about is this, which is bromine. So this should be the answer. Oxo acid, oxo, then an acid, OCl2, OCl, whatever. So that will be the answer. So the next one now should be, what is the physical state of hydrogen fluoride? Please note the physical state of hydrogen fluoride. Hydrogen fluoride is liquid. Please keep that in mind. It is not a gas. Hydrogen fluoride is liquid. So that is the answer to that question. Nothing to talk about, but keep it in mind. The next one. In which of the following hydrogen bond is not present? Hydrogen bond is a reaction between hydrogen and any other highly electronegative compound. I've given you the trend before. So hydrogen plus any of these is what we call electronegative. So you can see how this one is forming. I didn't put C here plus hydrogen. Hydrogen is not even present here. So this is an answer to this. This is a simple question you can expect at any level. The next one. Hydrogen bond is formed in HF due to dash. Now, the hydrogen bond that is formed in this is because hydrogen bond is what we can say small size of fluorine, high electronegative of fluorine. Hydrogen bond is formed between, no. The size of an atom does not actually justify, whoa. Yes, it's correct. Yeah, I will explain why it is correct. We have to understand. It is not about crime, it's about understanding. Now, I said something. I said fluorine is highly electronegative. That is why it's formed hydrogen bond. Most hydrogen bonds are formed as a result of what? High electronegative between what? Hydrogen and high electronegative substance. But chlorine is also having what? A short bond length because they what? Because of from the theory of VSEP, valence electron, whatever, valence shell electron repulsion theory. Fluorine bond are very, the bond length is short. They are very, very close because they are almost close to an octet. So because of that, they easily clamp themselves together with hydrogen. So it's a good reason you can also pick. Again, when you have an object that has both something, you can always think very well before you pick an answer. Please note that. The next question. I hope you guys are not tired. Watch the video to the end. We are almost there. Hydrogen halide which have bigger size and less electronegativity are dash. It's a simple thing. So they are liquid. So we don't need to waste our time on that. The next question. We've talked about it. The next question says, the affinity of hydrogen towards it is in the order of affinity of hydrogen towards halogen, I guess. Maybe hydrogen and halogen. I think maybe that is what the question is asking. We know that hydrogen fluoride is greater than hydrogen, bromine, chlorine, fluorine, whatever arrangement. Then it's greater than, I said FON Cl, then you can continue like that. So then it's more. Fluorine is greater than chlorine, is greater than bromine, is greater than halogen. Nothing to solve in this type of question. They are simple questions you can actually get from the knowledge of what? The electronegativity trend. It's a simple question. We have talked about it. The next one. The acidic strength of hydrogen halide is in the order of dash. Now, be careful about this acidic strength of halides. Increases in the order of what? It moves from the way I always tell students, it negates what you are what we have been talking about. That is everything start from fluorine, hydrogen. This time around, in terms of acidic strength, because of the pKa of fluorine, what we notice is that iodine tends to react more, have more acidic strength than fluorine. Then after iodine, we talk about chlorine. Then after chlorine, we talk about bromine. Then you now talk about the fluorine. So it is just the opposite of what we've been talking about all since morning. So I think the correct trend from what I've explained is that it is not greater than, it is less than, this particular thing in less than, option B, answer. Please, that is the acidic strength. Please note that. Note that it's very important to keep that in mind for those A-level students. The next one, the stability of hydrogen halide. The stability of hydrogen halide. So I told you stability of hydrogen, that is hydrogen fluoride, hydrogen bromide, hydrogen iodide. The stability is what? It's just in the order of what? Their strength. Talking about hydrogen fluoride is more stable than hydrogen chloride, and it's follow the trend that you know before. So the same trend of chlorine, chlorine, bromine, iodine, and what, and so on and so forth. So that is the way the stability. The stability is owing to the fact of what? Of the hydrogen bond, the strength of the hydrogen bond. So the stability follow that same trend of fluorine, chlorine, bromine, iodine, and what, and the rest. So the next one, the correct order of melting point of hydrogen halide is dash. Now, melting point, melting point. Let it be known that every other one, every other substance they do have a negative melting point. So it should be in the order of fluorine, chlorine, bromine, whatever. Just be careful about your answer in terms of inequality, because sometimes you might miss inequality. So be careful about that. Check the inequality very well before you pick an answer. Please watch this to the end. The next one is, which of the following oxide of fluorine does not exist? I told you fluorine oxide is O2F2 and OF2. I talked about that the other time. So this does not exist. So this is the answer. In fact, this one is said to be, it's not stable. This guy is stable about at the temperature about, I think a temperature about, let's say 273 or 573, something around that. So it's not, it's stable. So this is unstable and this is stable. So please keep that in mind. So there's nothing like O2F3. Keep that in mind. There's nothing like odd what? Odd function of what? Of fluorine with oxygen. That is just a logic to remember. Next one. The next question is which of the following fluoride is thermally stable at 298? You know, I told you just now. This is what I said. At 298 Kelvin, this is stable. Stable at 298. 298 Kelvin. This is stable at 298. This is not stable at 298. Please keep that in mind. Next question. Now, both OF2 and O2F2 are dash. I talked about them. I said they are what? Fluorinating, even though my spelling was wrong that time. Fluorinating agent. They are used to what? They are used to obtain plutonium from a mixture of what? Other gases. Now, please note that. The next question should be, my admin, please, you have to be up and active. We have O2F2 oxidizing plutonium. It's oxidizing, it is used. I told you this particular O2F2 oxidizes plutonium to form PuF6. So keep that in mind. It's a direct word I've explained before, so I don't think I have to waste my time on that. The next question. The next question says, the higher oxide of halogen tends to be dash than the dash. The higher oxide of halogens are more stable than the lower ones. So keep that in mind. This is the answer to that. Higher oxide of halogens are more stable. They are more stable than the lower ones. The next one is because of the oxidation state. So if you ask, now how many given chlorine oxide are highly reactive oxidizing agent and tends to explode? Now, almost all the oxides of I told you are what? Are explosive. All chlorine, oxide of chlorine, explosive. All oxides of chlorine, you can write it, all oxides of chlorine, line by line, are explosive. My admin did not finish up this work, are explosive. So this is not an oxide. So all these 1, 2, 3. So the answer here is all these 3 are the oxides I think I wrote it very well. In fact, this Cl2O2 is used as a powerful oxidizing agent. It is used as a bleaching agent. And also used in treatment of downward. Treatment of downward. Please don't be tired. Try and watch this video to the end and make sure you are writing down. It's important you are writing down, because if you don't write down, what you don't know about chemistry is that as you are enjoying it now, getting them, when you don't write it down, next time you forget one or two lines, you won't see something to fall back to. So you have to write down, and that is why we are bringing it in terms of line by line questions. We help you to what recall them whenever you need them. So treatment of downward, which is one of the use of what of chlorine. You know that very well. The next one, we are almost there. The next question says, which of the following chlorine oxide is a bleaching agent for paper pulp and textile in water treatment? I just talked about that. It is not this one, but what? But this one. So all oxide of chlorine, Cl2O, ClO2, Cl2 O7, Cl2O3, and so on and so forth. But this particular one, it's a bleaching agent, and it's also used in treatment of water. So keep that at the back of your mind. The next one, we are doing line by line concept response question, which we think is the best way for you guys to know chemistry very well. And this is what I think I will do for all the topics by the grace of God. So stay with this channel, subscribe, and do expect the best from us. The next question says, which of the following iodine oxides is or are not known? I think I list out all these things the other time. If you still remember, I told you we have I2O3, I2O4, I2O5, I2O7. I never talk about I2O6, about the oxides of. So we are talking about oxides of halogen now. So I2O6 is not. In fact, I said this I2O5 is used as a powerful oxidizing agent. An oxidizing agent. So it's not just an oxidizer, a powerful oxidizing agent. You can see I say powerful. So there's nothing like I2O6 as an oxides of iodine. So the next question, dear student, will be halogen reacts with metals to form, we've talked about this, halides, metal halides, metal halide and non-metal halide. They react with metals and non-metals to form halides. Next question. We have 100 questions to solve. I think we are almost there. Admin, are we almost there? Thank you very much. Admin, please be watchful. What product will be formed when bromine reacts with magnesium? We've talked about reaction of what? Halogen reacts with metal. So we are in the reactions of halogen now, I guess. So reactions. Plus, you have to listen and watch this video till the end. Magnesium is Mg2 plus. Bromine is Br minus. Cross multiplies is Mg, capital M, MgBr3. You know it very well. So this will be the answer to that. So reactions are what we are talking about now. Keep them in mind. They are very important too. The next question. The next question says the ionic character of halides. The ionic character of halides decreases in the order of dash. Now, okay, decreases. So when we talk about ionic character, so just listen. Wow, sorry. Now, ionic character. I've talked about our covalent character. I said they move from fluorine to chlorine to bromine to iodine. So if it is ionic character, ionic characters are measured in terms of when they combine with metals easily, they combine with hydrogen, they form ionic bond. You know that. So now, when they combine with, because we are talking about them, so they increase in this order too. So, but the examiner asks for decrease. So ionic character also is like this. They move like this, your normal form, MF, MCl, M whatever. But if it is covalent character, it will now be the reverse of this. In fact, the covalent character, if it is covalent character, let me write it in language form. Character. We use the oxidizing agent. We use the oxidizing state. Oxidizing, permits me, guys, about my spelling state, to know the one with highest covalent character. But for ionic character, they follow this trend. But for covalent character, we use what? Oxidizing state. OS. Calculate the oxidizing state. You are going to know the one that has the highest covalent character. I hope I am communicating. So in this class, we are talking about the decreasing order. Fluorine is greater than, so it's like this. Fluorine is greater than, chlorine is greater than. I hope you understand. So you follow the same trend you have been picking since morning. The next one. Choose the correct statement regarding metal halides. So to know the metal halides, I told you when they combine with metal halide, you can say covalent character. When I tell you about covalent, use the oxidation state. Now, you don't need to waste your time. For covalent character, use the oxidation state. Oxidation state of 4, this is 4, this is 2. 4 is more than 2. So this BCl4 is more covalent than this. This is correct. PbCl2 is less covalent because this is 2, lead 2, and this is lead 4. I hope you understand. So that is the logic about metallic, because most questions, even UTME students, they ask you, and in the metal halide, which one is MCl, AgCl, if it is covalent character, use the oxidation state. If it is ionic character, don't use the oxidation state. Use the trend of fluorine, chlorine, bromine, and what? And iodine, which you have learned from this concept and line by line class. So let's move on to the next class. We are almost there. 100 questions for halogen and its compound. I will also talk at the end of the video to some other things maybe I didn't finish up, because I still think there are still more for you guys to learn, but I want to just try to make sure you get it. The question says, halogens combine with amongst themselves to form a number of compound. Know that what I talked about that. I told you the other time, interhalogen. When halogen combine with halogen, not intra, but interhalogen. And it is not inter-system, because some of you, when you see one vocabulary in question, that is what you are going to pick. So let's just move on. Apologies, I need more water. Now, next question. The next question is which of the following interhalogen does not exist? Halogen plus halogen makes what? So oxidation state of halogen, I told you, are 1, 3. You can say plus 1, plus 3 because it's important, plus 5, and plus 7. It is only fluorine that has only one oxidation state, and that is why, because absence of d orbital. I talked about that. You remember? So interhalogen also obey XX, SX3, XX5. Halogens are X, and XX what? 7. So the one that does not exist is what? Odd numbers. Even number does not exist. Odd number exists. Another logic. There are different logic you can use to know these things. That is one of the logics you can keep in mind. Next point. Now, what are the products of X and Y in the given reaction? I think we are now in preparations. Now, preparations of chlorine. A quick fact, so that we are going to increase our pace while picking answers. Chlorine is prepared in the laboratory by action of oxidation of manganese 4 oxide on hydrochloric acid. I'm not balancing. You can balance MlCl2 plus water plus chlorine gas. Chlorine gas is less denser. It is 2.5, about 2.5 denser than air. So it's a gas. It's the style we've talked about fluorine and chlorine and gas. Now the other ways to prepare chlorine. This is the whale shell, or whatever you call it. This shell in 1774 to be precise. Just a quick fact you can write down, produce its own what? Chlorine. But the other way, by using potassium permanganate, KMnO4 plus hydrochloric acid. This is another way you can produce that. The same process, you get the same way. You know what I mean by the same process, the same way. You balance the equation. Another way you can also produce this is you can also produce it from a method we call Deacon's process. Deacons. Is it Deacon apostrophe S? Deacon's process. Now about Deacon process, that is just mixing hydrochloric acid. You can see every one of them is having hydrochloric acid. So it's a simple way to recall. Hydrochloric acid with what? Atmospheric oxygen. In the presence of what? CuCl2 as a catalyst. So that is Deacon process. Then the same process you can see. That's that. So another way you can also mix sodium chloride. Sodium chloride with potassium permanganate with water. You can also do that also to liberate what? But these are the most important one. It is collected, you know very well, chlorine is denser than air and it is soluble in water. You understand that? So it is collected by upward displacement of air. Upward displacement. Basic questions of air. Upward displacement of air. So please note that. So now in this question, manganese oxide is combining with this. S will be MnCl2 plus this. Direct answer. I think this thing is loading. MnCl2 and Cl2 directly we can pick this. Yes, it is loaded. So that's the answer. Choice C will be correct to this one. I hope you understand. Talking about preparation of chlorine. Watch this video to the end. You are almost there. Don't rush. You are almost there. So the answer to that question is choice C. Choice C is correct. So we can say this is the answer to the question. The next question. The next question says, which of the following alternative can be used in place of hydrochloric acid during the preparation of Cl2 and Cl2 from MnO2? What did I tell you about that? I said you can actually mix what? NaCl. I was talking about that the other time. Okay, I think I was talking about it with NaCl plus what? H2SO4. So please note that. I think I stated it, I didn't write it down. So now we can use NaCl plus H2SO4 when what? HCl is not present. So that is another way of preparing chlorine. Keep that in mind. The next question, line by line. Thank you very much. What are the products obtained when NaCl plus MnO2 plus H2SO4? You can see, you don't need to waste your time. The same concept. This is MnCl2, just balance equation, plus NaHSO4 plus water plus Cl2. So look for what is like this. So we say it's an alternative method by using NaCl and H2SO4 with manganese oxide. So to produce what? Chlorine. So, and these are the products of what we are going to get. Which option goes with what I've written? Plus water. Yes, this is it. Answer. The next question. I hope you are following line by line. We are almost there. Chlorine can be obtained by action of HCl on. You say another method is what? By using KMnO4. Remember, you have forgotten? Don't forget. I list that out when I was telling you about concept. This is it. And this, you can see KMnO4 plus what? Plus hydrochloric acid. So KMnO4 is another alternative you can use to produce chlorine. The next question. Now, which of the following process is used to manufacture of chlorine? ABA is for ammonia. I hope you still remember. Oxoacids is for HNO3. Answer to question is what? Deacon's process, I talked about that. All ORAT is for aluminium. So you can keep that in mind in future questions. You can come across that. Next question. Now, which of the following is involved in Deacon's process? I think I explained Deacon's process the other. Atmospheric oxygen with what? With hydrochloric acid gas in the presence of catalyst. What's the catalyst? Copper chloride. Just look for the language. I think this is it. This is answer. We can move line by line, almost there. Now, what is the temperature required for Deacon's process? I may not talk about it, but now keep it in mind. Deacon process is about 723 Kelvin. So this is the temperature Deacon's process. So during the Deacon process, you need about high temperature of about, in the presence of catalyst, which is copper chloride, CuCl2. So answer is nothing but this. Watch this video to the end for maximum knowledge. Now the next question says, hope I did not jump to questions. Thank you very much. Now, which chemical compound solution undergo electrolysis to obtain chlorine? Industrially, chlorine is obtained industrially by electrolysis of iron. Chlorine is obtained by electrolysis of brine. Good. So now chlorine is obtained by electrolysis. Brine means concentrated sodium chloride solution. So chlorine is discharged, Cl2 is discharged at the anode. Watch this video to the end for full concept video. Now, the answer is just brine electrolysis, nothing to talk about. Next question, please. The next question says, which gas is related at the anode? We just talked about it. That is the answer. I think you guys are following, doing what? Brine electrolysis. Next question. Chlorine is a dash. We've talked about the color of chlorine, greenish yellow gas. Is an answer. Next one. Apologies. Chlorine is, I said it is 2.5 heavier. It has a pungent odor. Excuse me. It has a suffocating odor. Then the answer to the question is all of the above. Next question. That is why it is start by upward displacement. Chlorine can react with that. We've talked about this. Chlorine reacts with metal and non-metal. Metal halides and non-metal halides. So we've talked about it. Both A and B will be the right answer to this. My admin like repeating question. They want it to be line by line. It's not an easy work, to be honest. Now, what is the product? I think is reaction of P in the reaction. So I think P should be what is here if they react. So let's do it. Let's do it. Now, chlorine reacts with non-metal. One of the non-metal, watch the video to the end for maximum knowledge. Because not all what I'm going to be saying about is what you see in question. So that's why I asked you to watch it to the end. Now, when chlorine reacts with sulfur, sulfur is in with chlorine. It's 4 moles of chlorine to give you S2Cl2. So this is the way we do it. Then this is also going to be 4. So this is the way it reacts with sulfur. Sulfur is a non-metal. Chlorine is also a non-metal. So chlorine reacts with non-metal. Not only that, as non-metal, there are other non-metal that chlorine also reacts with. Chlorine also reacts with phosphorus. Phosphorus plus chlorine. It depends. It can be PCl3 and it can also be PCl5. You guys know very well. So that is the two way. Another one you can keep in mind. It's also very common in question. Chlorine also reacts with their other non-metal. It is not only this. Chlorine also reacts. Why am I saying fluorine? Chlorine also reacts with not only phosphorus. It can also react with another non-metal apart from phosphorus and sulfur. So apart from that, they also react. They combine with I want to use an hydrocarbon. Yes, they combine with methane. You guys know that very well. Substitution reaction, right? In the presence of light. Very important for you to keep in mind. So they react with hydrocarbon. They only react with hydrocarbon to give us, you can say tetrachloro, final product, tetrachloromethane, popular in junior classes. So that's also very important for you to keep in mind. So they also react with oxygen. We've talked about the oxygen format, OCl, OCl2. You remember that or you've forgotten? That is why you have to write that. Then you go through the notes. Before you know it, you become master of all this stuff. So the answer to this is this guy. And we can move to the next question. Yeah. The next one, we are in the reaction. We are almost done. Chlorine reacts with compounds containing hydrogen to form dash. Chlorine plus hydrogen. That's very simple. That is halide. So be careful about that. Chlorine combined with hydrogen. Chlorine. Everybody know. Hydrogen chloride, which we are still going to talk about maybe in the next chapter. But don't worry, hydrogen chloride, talking about aqua regia and stuff like that. Now, other reaction of chlorine. Chlorine can react. You can just give this short note. Chlorine can react with sodium hydroxide. It is in two ways, hot and cold. I can just take it cold and hot. So if chlorine reacts with, I told you chlorine has multiple oxidation states, unlike fluorine. They can be 1, 3, 5, and 7. So when they react with cold NaOH, this is also common. You expect them to give you NaOCl. They call it hypochlorate, hypochlorous. Anyhow you call it, hypochlorous acid. So you can finish it NaCl plus NaCl plus H2O. But if it is reacting with hot, oxidation number is changing. Hot alkali, you know this is called alkali. Other reaction important, it will give you chlorate, NaOCl3. So this is chlorate. So that's the difference. This is also common. You can keep it in mind in some reaction of chlorine. Now, chlorine can also react with slake like calcium hydroxide. Apology, this thing is loading. Concept before question, calcium hydroxide plus chlorine. So when chlorine reacts with calcium hydroxide, it gives you the bleaching ability of chlorine. This is the reaction you were told in junior classes. CaOCl2 plus CaCl2 plus water. So this is water. This is what they call the bleaching agent or bleaching powder, the way you put it. So answer to this one is this. We can move on to the next one. Hopefully we are almost through, and that is why I'm giving you some other thing. The next one is identify the product of X and Y in the reaction. Hydrogen sulfide combined with chlorine. Chlorine can also react with what? With hydrogen sulfide to deposit sulfur. We said chlorine is an oxidizing agent. Chlorine is an oxidizing agent. Because it's an oxidizing agent, it will oxidize hydrogen sulfide, and it's going to combine to give hydrochloric acid. You know, addition of hydrogen is reduction. So any compound that got itself reduced is called an oxidizing agent. So this is just a reaction of oxidizing ability of what? Of chlorine. So you can just write the chemistry of action. H2S plus Cl2 will give you HCl plus S plus sulfur. Balance the reaction. So keep that at the back of your mind. This is the answer to that. That is what chlorine is acting as an oxidizing agent. Thank you, admin. The next question, we are almost there. I think it is the last question now. Very good. Now, last question for today. I told you guys there's still more to talk about, but because of time, I only make it limited to 100 questions. I hope you guys do enjoy this section. What products is obtained when chlorine reacts with cold? Cold. Admin, thank you very much for putting cold there. So I just talked about that. When it is cold, it is what? Hypochlorite. When it is hot, it is what? Chlorate. So be careful about that. So it will be what? Hypochlorite, and it is not hypochlorite and chlorite. It is hydrogen and hypochlorite, chlorides and hypochlorite. So I think it's this because of the answer. We talked about it. You can write it with dilute alkali. That is our sodium oxide, potassium hydroxide. So please note that. So that's what they are going to form. And I think that's the last question for today. Guys, if you, we still have one more question to go. That's the last but one. The last question, which is the 100th question for today, is what is M in this reaction? You just need to know what is being reacted. So NaOH plus Cl2. So NaCl plus, I think I wrote this reaction before, but be careful about it. If it is NaOCl, so NaOCl, this is what? Hypochlorite. So which is this. If it is the other one, it will give you NaClO3 plus NaClO2 plus whatever, plus your salt and your water. So that is how we do it. So please be careful, and that is chlorate. NaClO3 is called chlorate, not NaCl, NaOCl3. It is NaClO3. So I can correct that here because I think there was a mistake here. I try to make sure this video, okay, this is it. You can see ClO3. So it should be NaClO3. So that is hot. So NaOCl, please note that, and that's the difference between the hot and the cold alkali. So guys, I'm stopping here. I hope you enjoyed this concept line by line video and this pattern for you guys to understand chemistry better. If you find anything interesting, do subscribe and share the content, and you can also drop a comment box. Next class, by the grace of God, I'm going to another topic, maybe nitrogen and its compound or oxygen and its compound. I'm going to take one command for you guys to get familiarized to reactions and behavior of compounds. So when we are through with physical chemistry or the inorganic aspect, we move to organic compound. We have a long way to go. We talk about all these elements one by one. Hopefully, you guys will enjoy chemistry, especially with us here. So this is how we do for all our students that are actually taking online courses. You want to be part of them, you can actually write a mail to mostiacademy@gmail.com or kindly send a word, call the number that is scrolling down on your screen. I'll see you guys soon. You have a wonderful time. Thank you and remain blessed.